So your question is, here we have, we add the power, right? So this is 2. And in this line, where? So why don't we add? Okay, let me explain again, then it will be clear. And if it is not clear, then you can tell me, okay? So we know this formula. dy is equal to y derivative dx, right? And this part here in the question, so we have u and dx, u and dx. So if you take this derivative u dx, so if you take this derivative on another side, okay, or maybe you can just multiply, you can just multiply integration sign on the both side, okay? Then integration of y dx. No, not this way. So here we have x dx, so we have to convert it something like dv, or you can also say, yeah, dv. So we need to find what is this v, okay? What is this v? So our Laoshi explained like this way. Where is the example? See here, example 3. We have integration of x cos x dx. So we have here like cos x dx, and we have to think how can we convert this cos x dx to something like dv, okay? To something like dv, because we don't want dx here. We don't want dx here, okay? We want something like dv. So so we have to think of the derivative of which function that is cos x, or just find the antiderivative of cos x, okay? So that means if we want to convert this cos x dx to something like dv, to something like dv, so why we are converting it to something like dv? Because from the integration by parts rule, we have dv, right? You see here, integration of u dv. This is the integration by parts rule that we are talking today. So we have here dv. Lucy, can you see here?
Yes, okay.
Okay. So that's why we have to convert this cos x dx to dv. So we have to think of, or we have to just find the antiderivative of cos x, okay? So antiderivative of cos x will be sin x. You see here, I just write down a small question mark here. You see?
Yeah.
That means we have to find this value. So we to find that value, we need to just find the antiderivative of that function. So antiderivative of cos x will be sin x. So we write down d sin x, okay? Instead of cos x dx. Instead of cos x dx, we write down d sin x. So here our v is equal to sin x. So yeah, d sin x plus c cos x dx. And here is some small explanation. So you see here d sin x plus c. That means derivative of sin x plus c, it will be cos x dx. Okay. Yeah. So that's why we are finding the antiderivative value. We to convert this cos x dx to something like dv, we are finding the antiderivative of cos x, okay? So if you understand this part, then we can come here. So from this selecting principle, from this 5 selecting principle, we get ln x in the second number, right? We get ln x in number 2. So that means we have to let ln x is equal to u, okay? So now what we left? We have x dx left, right? We have x dx left. So we have to convert this x dx into something like dv, right? So for that reason, we have to find the antiderivative of x. So am I right, Lucy? Lucy, can you hear me?
Yes, I can. Yeah, I'm following.
Yeah, so am I right? We have to find the antiderivative of x, right?
Yeah.
So antiderivative of x, that means integration of x dx. Integration of x dx, right? So integration of x dx will be x square by 2. Okay, from the formula. Because we just add on the power. Also, we divide by the power.
Divide by the power.
Yeah. So the antiderivative of x will be x square by 2. You got it?
Mm-hmm.
And you see here we have a formula. So from this line we get this line, okay? Until now from this line we get this line. Now let's think about the next line. So here is a formula, that is integration of u dv, right? This is our u and this is our v. So integration of u dv. So where is the formula? The formula, it is a formula that is called integration by part formula, okay? So this is our topic today. So integration of u dv is equal to u multiply v minus integration of v du. So it will be u multiply v. You see here u is ln x and v is x square by 2. So ln x into x square by 2 minus integration of v integration of v du, right? So this is our v x square by 2 and this is our du, okay? Du. So do you understand the second line?
Yes.
Okay. Now let's go to the third line. So now we can just take this on the left side and d ln x. So d ln x will be ln x derivative dx, right? From this small formula. So ln x derivative dx, derivative of ln x is 1 by x. Okay. And here is our dx. So you see here we can just cancel on x here. So we get integration of x dx, and we can take this constant out, right? So half integration of x dx. So do you understand up until this?
No.
No?
No.
See here, d ln x. So we know a formula, dy is equal to y derivative dx. So we have here d ln x. So we can write down ln x derivative dx, right? From this formula. D ln x is equal ln x derivative dx. So derivative of ln x will be 1 by x. This is also another formula of our differentiate formula, okay? Differentiation formula. Ln x dx derivative is 1 by x. 1 by x dx. So d ln x, it will be 1 by x dx, right?
Yeah.
You see here, I
Okay,
explained here. Okay.
Got it.
Yeah. Now, if you cancel x and x square, so you will get only on x here, right?
Yeah, X.
Yeah, so we have here x square and we have here x. So if we cancel these two, that means if we just divide by x on upside and down on and downside, so we get uh, integration of x dx. And this 2, this 1 by 2, we can take this out. Okay, so we take this out of integration sign. So ultimately we get half integration of x dx. And we already know the formula of integration of x dx. It will be x square by 2, right? X square by 2. X square by 2 plus c. So now this half and this half, they will make 1 by 4. Okay. So ultimately x square by 2 ln x minus 1 by 4 x square plus c. So Lucy, do you have any problem now?
No.
What about Topu and Julian?
I got it. I understood that.
Okay.
No problem.
Yeah. So Lucy, could you please tell me again about where you wanted to understand before, like which part?
You just explained it. It was here. It was here. Highlighted. It was here, but yeah, from explaining, so I'm clear now.
Okay. Yeah. Okay.
Thank you.
So we can now go to the next question. So here we have integration of x cos x dx, right? So again we have to use integration by parts rule. So now think of this principle. So we have cos x, that means we have a trigonometric function, and then we have x, that means power function, right? So here power function is on the upside, so we have to let power function as u. Am I right? So x, we just let x is equal to u from the principle for selecting u. So here u is equal to x, and on the right side we have cos x dx. We have to convert this cos x dx to something like dv, right? dv. Okay, so we know that for that reason we have to make the integration. We have to find the integral of cos x. So you see here, v derivative is equal to cos x dx. So v will be sin x. That means I just take this integration sign on the right side. So I just take this derivative side from left to right, and it becomes integral sign. Okay. V derivative cos x. Okay, let me explain a little bit here. This is v dx. So if we want to find v derivative, so v derivative is equal to cos x. V derivative is equal to cos x. Cos x dx means v derivative. Okay. Okay, I don't need to explain this way. So you see here we have cos x dx. So we know that if we want to convert this as dv, we need to find the integration of cos x, right? So integration of cos x will be sin x. So our Laushi just wrote here like this way. V derivative is equal to cos x. So if we take this derivative sign on the right side, or you can also say if we just multiply a integration sign here and here, so this integration sign and derivative sign, it can get cancelled, so we get only v, and integration of cos x dx, so it will be sin x, right? Guys, can you understand? Can you understand these two lines?
Yes.
Yeah, I understand
Okay.
derivative, but take this. I can
So
do this.
to make it
I can
simple,
understand.
if you just take this derivative sign on the right side, so we know that plus becomes minus, okay, and multiply becomes division. So like the same way, when derivative goes from left to right, so it becomes integration. Okay, guys, because integral and differentiation, they both are the opposite function. So next we have something like, so we convert it like sin x, so we will get integration of cos x dx. This will be integration of x d sin x. Am I right? So this was our planning. We wanted to convert this cos x dx to something like dv. So here our v is equal to sin x. Am I right? X sin x, x d sin x. Tapu, do you understand?
No, bro, but I'm facing some problem.
Okay. So here
Slide.
we know that previously we know the formula, that is integration of u dv is equal to uv minus integration of v du. So we need dv from the formula, we need dv, but here we don't have dv, we have here dx, right? So and if you look at
Yeah.
other things here, so here we have cos x and we have x. So from this principle, from this principle, from the selecting principle for u, we know that firstly we need to select the power function, and lastly we power function as u, and lastly we have trigonometric function, right? So you see here we have cos x, that means trigonometric function, and x, that means power function. So we already let x is equal to u. So now we only have cos x left, right? We only have cos x left.
Yeah.
So what can we do? We have to convert this cos x dx as dv, okay? And to convert this as dv, we have to find the integral value of cos x, okay? So integration of cos x will be sin x. So for this reason, I just write down here v is equal to sin x, okay? Now if you substitute here, so we get integration of x sin dx, okay? Integration of x cos x dx, it will be Integration of x d sine x. Tapu, can you understand?
Yeah.
Okay, Julian, can you understand?
Yes.
Okay. So this is the formula integration of u dv. So we can just write down u multiply v minus integration of v du. Okay. So this part is same, and integration of sine x dx. We know from the formula integration of sine x dx, it is minus cos x plus c. Okay. Integration of sine x dx, this is minus cos x plus c. So finally, this is the result. Lucy, do you understand?
Yeah.
Okay. Topu, do you understand?
Yeah.
Yeah, okay. So let's go to the next question. Oh, we have another way to solve this. So I just told you about this way, okay? As I explained above, I told you about this way. You have to think like what will be the value here. So you have to think of derivative of which function is cos x, or you can also just you can also just find the antiderivative of cos x. So antiderivative of cos x, that means integration of cos x, it will be sin x. So our v is sin x, and we can just apply the formula here. Integration of u dv, that is u multiply v minus integration of v du. Okay. So integration of sin x, that will be minus cos x plus c. So this is the answer. So I think maybe this way is very easy, right? This way is easier than before,
Yeah.
than the first way. Okay. But also you can use the first way also, okay? No problem.
It's very simple. From the number way one.
Yeah. But way on is also simple in the sense of you just have to let this function as v derivative, okay? This function as v derivative.
Yeah.
Okay. Then you multiply integration on the both sides. You multiply integration here and also here. Okay. So integration and this derivative sign get cancelled. So you get only v, and integration of cos x will be sin x. Here will be a plus c, okay, sin x plus c. Okay, but for this we don't write plus c, because we will write plus c at the last, okay, at the last part here. Okay.
Yeah. We can move
So
on.
guys, I think we can move to the next question.
Yeah.
So here we have integration of x e to the power x dx. So again, go back to our selecting principle for you. So firstly, that is inverse trigonometric function, log function, power function, expo function, and trigonometric function. So I can make some rhyme. I can make some. I can make it simple to remember, like I and L, P, ILP, E, ILPET. Huh? So you can just think about I love pet or I love my pet, okay? So guys, do you have any pet in your home?
No.
Okay, I love pet. So this is the selecting principle, okay? So I made this trick just now, okay? So I love pet, that means I for inverse trigonometric function, love, that means L for log function, and P for power function, E for exponent function, and T for trigonometric function. Okay, I love it.
Wow. Nice technique.
Yeah. So this is the formula of Omar. Okay, maybe this is I'm
Yeah.
going to write another
Intelligent
another
robot.
I
book.
like him. Omar's
So
theorem.
yeah. Omar's theorem. Yeah. So let's move on here. So number 4, we have integration of x e to the power dx. So remember, I love pet. So this is power function, right? And e to the power x is exponent function. So I love pet. So here we have a power function at the top, right? And then function, exponent function. So we have to let u is equal to x from this principle. So if we let x is equal to u, then we have to convert this e to the power x dx to something like dv. Okay, am I right? We have to convert this e to the power x dx to something like dv.
Yeah.
So for this reason, we have to find the integration of e to the power x. So integration of e to the power x, it will be also e to the power x, right? Integration of e to the power x, this is e to the power x plus c. But for now, we do not write plus c. We just write v is equal to e to the power x. Okay. So if you look at the formula here, integration of e to the power x, where is the formula? Yes, here, integration of e to the power x dx, it is e to the power x plus c. Okay. So
Okay.
so we can write down v is equal to e to the power x. So now integration of x e to the power x dx, we can also write down this way, integration of x d e to the power x. Am I right?
Yeah.
So from the integration by parts formula, it will be u multiply v minus integration of v du. Okay,
Yeah.
u multiply v minus
Yeah.
integration of v du. So it will make x integration of e to the power x dx. It will be e to the power x plus c, right? So this is the final answer.
How can you get it? I
Sorry,
can understand the last part.
you
How
don't
can we get it from the ex by dx result? Ex plus c.
Oh, okay. So here is the formula. Integration of e to the power x dx is equal to e to the power x plus c. This is the basic formula. Okay.
Go back the answer, please.
Yeah.
I need to say that.
Integration of e to the power x dx. So from the formula, we know that it will be e to the power x plus c.
Oh, okay, got it.
Yeah, I can also show you the notes of lecture 10 and lecture 9.
After the class, please give me the PDF file.
Yeah, of course I will be. What is that?
Any
November.
homework for this week?
No, maybe no homework for this week.
Okay.
See here all the formula. I talked about this in the previous class. Integration of k
Yeah,
dx
I
is
know
equal
that.
kx plus c. Integration of x to the power n dx equal 1 by n plus 1 into x to the power n plus 1 plus c. Integration of 1 by x equal ln x plus c. Integration of cos x will be sin x plus c.
Yeah.
Integration of sin x will be minus cos x plus c. Integration of e to the power x dx is e to the power x plus c. Integration of sec x squared x
Yes.
dx equal tan x plus c. And integration of sec x tan x equal sec x plus c. Okay. You see here, we just keep this sec x
Okay.
here. Okay. Integration of sec x squared x dx equal tan x plus c. Okay. And integration of 1 by x square plus 1 is arc tan x plus c. Okay. And integration of 1 by root over 1 minus x square dx, it will be arc sin x plus c. So this is the basic formula. Okay.
Yeah.
Square plus 1 arc tan x, 1 minus x square is arc sin x. Okay. So let's go to the next example. We have integration of x e to the power minus x dx. Integration of x e to the power minus x dx. So again, you see here we have expo function, and also we have power function. So from my formula, you know that we have to let x equal u, right? So
Yeah.
if x is equal to u, then you have to convert this function to like dv. So you have to make the integration of, you have to find the integration of e to the power minus x, right? E to the power minus x. So e to the power minus x, integration of e to the power minus x. So you can just take this power down, okay? It will be minus integration of e to the power x and minus integration of e to the power x. So we know that sorry, I have to write down also dx here. So from this part we can just take this minus out, right? So we get minus integration of e to the power x dx. And now we know that it to the integration of e to the power x dx, it will be e to the power x plus c, right?
Yeah.
And here we get a minus.
Y minus. Oh, okay.
You see here,
Got
we
it.
just took this minus sign out of here. So no, I just skipped some part here. So I need to explain it again. So you see here we have integration of x e to the power minus x dx. So we are calculating this part here, okay? E to the power minus x dx. So it can be d into e to the power minus x, because we know that integration of this part dv. Okay, we can do another thing, that is, you see here we have minus x, right? So if we take
Yeah.
another minus here, just to make this these two, you see here. So if we take another minus here to make these to make these two variables similar, okay? If we just take a minus here, we also have to we also have to multiply a minus, okay? So that means for example, we have e to the power x dx is equal this function. Oh, Hassan is back. Okay. So guys, think again here, okay?
আরে ভাই তোমরা কি করতেছো?
We are studying integration by parts rule.
আচ্ছা, আমার তো জয়েন করার ইচ্ছা ছিল, বাট রাস্তায় আছি, অন দা ওয়েতে জয়েন করতে পারতেছি না।
Okay, no problem, Hassan. You can just
আচ্ছা,
you can
তুমি
just mute
রেকর্ড
yourself.
করতেছো না?
Yes, I am recording.
আচ্ছা, আপলোড করে দিও ইউটিউবে।
Okay. So see here we have e to the power minus x dx. So if there is a function e to the power x dx, and we have to convert it something like e to the power minus x dx. So I just multiply a minus here. So if I multiply a minus, then this minus will also multiply here and here, okay? So this will be e to the power minus x and d minus x, okay? E to the power minus x, d minus x. So you see here two variables are similar. So now we can just combine them and write down d into e to the power minus x. Okay, guys?
No more.
Okay, no, right? Okay. I will explain again. Okay, so x is equal u. Do you have any problem here? X equal u?
No.
Okay.
No.
And then e to the power minus x dx. E to the power minus x dx. So you look here. What I told you before. Think of derivative of which function is cos x. You see here? Okay. So now we have to think of derivative of which function, that is e to the power x dx, right? So we know that if we just make that means we have to find the integration value of this function. So it will be also e to the power minus x, okay? So guys, do you understand up to the up to this line?
Yes.
Kepu? Okay. So you guys can understand up to this line, right? Now. E to the power x dx equal d into e to the power x. So you see we have different variable here. We have e to the power minus x and we have dx. So if we have different variable, we can just take a minus here and also take a minus here. So it will be e to the power no. We cannot do that. E to the power. Okay, so we know another thing, that is the this formula e to the power x dx equal d e to the power x dy is equal y derivative dx. So this is our dy. So the value will be y derivative. That means 2 e to the power x derivative. That means also e to